Hello everyone. Welcome to this lecture on sustainability. Now the place to start when we're talking about sustainability is with the term sustainable development. Sustainable development was first proposed in 1987 by the World Commission on Environment and Development. And their definition of sustainable development is very important. It's something that a lot of people in industry, in government, in nonprofits, in international agencies repeatedly go back to this particular definition of sustainable development. Sustainable development has been defined as the ability to make development sustainable to ensure that the needs of the present are met without compromising the needs of future generations to meet their own needs. Now, there are two parts to this definition. The first is that you're talking about the needs of the present generation, so the needs of all the people that are currently living right now. And then you want to balance that with the needs of future generations to meet their own needs. Now, the key point here is the term need. Need, as opposed to want, are basic necessities that humans need to survive on this planet, primarily food, water, shelter, and clothing. And so as long as a generation is meeting the needs of the entire generation, and then you're doing that in a way that it doesn't compromise the needs of future generations to meet these very basic needs, then your model of development is sustainable. It is sustainable into the future. I think it's a very intuitive definition because it suggests that we shouldn't be doing anything that is preventing others from meeting the basic needs of their society. But when we think about sustainable development in a more functional way, it's about trying to create a balance between three fundamental entities, between society, economy, and environment. Specifically, when we think about sustainable relations, we consider these three entities of environment, economy, and society, and we think of the interrelations between these three entities. So, for example, between environment and society, we want to foster kind of life support relations. Between society and economy, we want to foster livelihood production relations. And between economy and environment, we want to foster economic throughput relations. In all these three kinds of relations need to be sustainable in order for the planet as a whole to be sustainable. So what do we mean by each of these aspects? So life support relations are the relations of how a society derives value from having an environment that it can draw its life support on. And in turn, the society manages and conserves the environment in order to ensure that its life support is maintained. And so this dual relation between life support and conservation and management is what ensures the sustainability of this relation. Now, there are challenges to this, and one of the major challenges is increasing human population. But it isn't just human population alone that is a challenge for life support relation. It's also the impact that humanity has on ecosystem integrity, and that impact is not just based on population alone, it's also based on the kind of lifestyle that we lead and the kind of resources that we use in order to maintain our existence on this planet. And that's where the question of livelihood comes in, because the question of impact is associated with the relation between economy and society, where society provides the labor that runs the economy, and society also consumes the products created by the economy. And in turn, the economy provides goods and services that the society needs. And economy generates capital, which again is used to provide labor to the economy. And so it's a very complex relationship, and it's called the livelihood relation, because in order for society to survive, it requires a form of livelihood, which is what the economy provides. Now, one of the major challenges associated with livelihood relation is the source of inequality, both economic and social inequality in our society. And this source of inequality is what creates a major challenge for unsustainability. The fact that a minuscule fraction of the global population consumes so much of resources and it has access to so much of wealth, whereas a large proportion of humanity does not have access to resources at all. And so this inequality is also a driver for unsustainability. And then finally, the throughput relation is the relation between the environment and the economy, where the environment is the source of natural resources and low entropy matter, which are required and used by the economy. And the economy, when it uses these natural resources, produces high entropy matter, which becomes the waste into the ecosystem or the source of pollution. And so this throughput relation also has certain challenges. And one of the major challenges is the size of the economy with respect to the ecosystem. As the economy keeps growing, the ecosystem remains finite and non-growing. And so there is a challenge at what scale of the economy are we going to reach the carrying capacity, the maximum carrying capacity of the ecosystem or the environment, and at which stage, when we cross that maximum carrying capacity, then we're heading towards some form of ecosystem collapse. And there are challenges. These challenges are visible in forms of global warming and climate change. It's also visible on a more less systemic basis compared to climate change in things like the Pacific Ocean garbage patch, which is this enormous swirling patch of plastic debris that's been circulating in the Central Pacific. So when we think of sustainable development, we are talking about balancing these three interacting relations of life support, of livelihood, and of throughput. So one thing that we want to talk about a bit more in depth is the relation between throughput and sustainable economy. So when we think about the ecosystem, we're talking about circular flows in the form of carbon cycle, in the form of how predator and prey relations are maintained. All of this forms within a circular kind of flow where there are natural feedback loops that limit the growth and change within these flows. On the other hand, economic flows and throughput flows tend to be linear material and energy flows that go from low entropy to high entropy. And so this can be a challenge primarily because the growth of the economy happens within a non-growing finite ecosystem. And so many years ago, the economy was a very small fraction of the ecosystem. But in the last 100 years, and certainly in the last 20 or so years, as a result of technological change, as a result of globalization, there's been an enormous growth in the economy. And this growth is happening with respect to the ecosystem, which remains finite and non-growing in some sense. And so we're getting to the point where many economists are talking about an economy within a full planet, where we're reaching the period where economic wealth, or GNP, global GNP, gross national product, is becoming increasingly very comparable to ecosystem services. Now, from this, this very influential paper by Robert Costanza and others, which tries to value world's ecosystem services and natural capital, you come with this figure, and this was way back in 1997, that the global GNP was about US dollar 18 trillion, and ecosystem services were valued on the basis of some calculations that these economists did, about $33 trillion. Now, the fact that they're very comparable should be a source of alarm. That is not to say that when one reaches parity, when global GNP reaches parity with ecosystem services, we are necessarily going to face ecosystem collapse. But it should be a worrying thing that global GNP is now very comparable with ecosystem services, and that we are reaching a point where we're not too sure about what could potentially happen when global GNP far exceeds the value of ecosystem services. So in this context of sustainable relations, what kind of technology and what kind of technological solutions do we need for sustainable development? So we're talking about along the same lines of those three sustainable relations that we talked about, of technology for life support, technology for livelihood production, and technology for economic throughput. And I want to kind of briefly talk about three directions that I think technological change needs to follow in order to attempt to be more sustainable in its footprint on this planet. The first, technological solutions for life support, which seek to increase life support. And how do we do that? One of the major things that we want to avoid is to reinforce the situation of carbon lock-in. And there are many ways of doing this by nurturing technological leapfrogging, a very quick and simple fashion which many people have already implemented, which industries have implemented, that governments have mandated, are energy efficiency and renewable technologies. But it's not just good enough to look at individual technologies. What you need is much more systemic interventions and systemic transitions, because one of the key objectives of this process is to break carbon lock-in. And the same is also associated with technological leapfrogging, where you create technological solutions that bypass environmentally unsustainable pathways, and you develop synergies that create new, more sustainable situations of lock-in. Technological solutions for livelihood improvement. And one of the key points that we want to do here is want to avoid laissez-faire forms of technological development and think about more democratic, socially innovative, gender-neutral forms of technological solutions. And so several methods and means of democratizing technologies, which I'm not going to go into great detail. You're welcome to read on your own. Forms of technological assessment, methods of improving the intelligence of democratic decision making so that you have technological developments that are much more appropriate to the context in which they're applied. And then, of course, social innovators, and I'm not going to talk more about this because there's a separate lecture on social innovation that actually focuses on this. But much of this innovation is motivated by social and environmental value generation that tries to address the needs of populations that have been excluded from mainstream pathways of innovation. We're also interested in talking about technological solutions for throughput reduction. And one key means of doing that, of decreasing throughput, is through kind of circular pathways of industrial processes, through what's called industrial ecology, kind of closed loop forms of recycling where the waste streams from one industrial ecosystem is transferred to another manufacturing group. And so an industrial ecosystem with interconnected kind of feedstock flows. A good example of this is the industrial ecosystem at Kalundborg in Denmark. So on a sustainability grid, what kind of interventions are we talking about? You're talking about trying to create an increasing life support mechanism, increasing livelihood mechanisms, and decreasing throughput. And so attain some kind of a sustainable sweet spot where we want to focus our efforts on technological innovation. Thank you.